only. You can show your strength reaction. You can show your surface reaction. We have root combinations. We have different options to show your results. Anyway, so we have B surface, dead and live fluid. We have B ultimate, which is factored reaction. What else? Third step. Find an approximate footing depth, HF, total thickness. HF, total thickness of footing. Your total thickness equal your depth. You know, we have something here called depth. Do you remember what is the difference between thickness and depth?
The rebound.
Cover. Just reminder, if you have cross section like this, and here is your steel reinforcement, your thickness is the total height. Your depth, this height. The difference in between the distance is called cover. So in foundation, we need your cover to be larger than 3 or 4 inch. Do you know why? Do you know why for foundation, your cover of concrete below steel reinforcement 4 or more, 4 inch? Why?
More pressure.
In the soil. Do you know what is in the soil? We have rainfall, we have sewer water, we have many things. So we need to protect our steel reinforcement. We need the thick cover to protect your steel reinforcement from soil. That's right. So that's the reason why we choose not 1 inch or 2 inch, 4 inch. And also your total thickness, something multiple of 2, 4, 6 inch, integer number. I'm sorry, should be integer, even number. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, not 21. For rectangular column, if you're footing supporting rectangular column, then you have to solve for this equation to get your depth. If you get your depth, add 4 to get your total thickness. If you're footing supporting circular column, please solve for this equation to get your depth. Once you get your depth, add 4 to get your total thickness. I'm sorry. What do you mean by this equation? Okay, 4D square, I'm looking for D. 2, B plus C. What you mean by B, what you mean by C, dimension of your columns. B and C, dimensions of the column. That means before designing foundation, you design the columns. D, I'm looking for D. P ultimate, factored reaction. 1.2 dead load plus 1.6 live load from the previous step. Divided by phi equal 0.75. Mu C equal 4 lambda square root of FC prime. Lambda equal 1 for normal weight concrete. So if you put dimension of your column, your P ultimate reaction on your footing, phi 0.75, PC this number, you have equation with D, one unknown, I can solve for D. Once you solve for D, add 4 inch, you can get the total thickness of footing. If your column is circular column, then I have to use this equation, D square, I'm looking for D, D, I'm looking for D, B ultimate is the same, phi, V, nu C, the same, but A, equal square root of pi d squared divide 4. But d here is the diameter of column. Be sure. Diameter of column. Your column is a circular column. It has a diameter d. So call it d capital, capital D. Don't confuse about this d and this d. Diameter of column. So A is the equivalent square column size for your column. Put A here, solve for this equation, you can get D. Once you get your D, add 4 to get the total thickness of your foot.
Dr. Ayman?
Yeah.
So, like I've seen on buildings where the columns, if they're rectangular, they get smaller and smaller as you go up. Are we just focused on that last column that's on the bottom?
We are designing right now your foundation. We designed column at the ground foundation.
Mhm.
Okay? If you would like to design another column, like this column is supporting only 2 floors or 3 floors, 1, 2, 3. So size of this column should be smaller than size of the same column at this location, because this column is supporting 1, 2, 3, 4, 5. But this one, 1, 2, 3, 4. This one, 1, 2, 3. This one, 1, 2. So if you have, if you would like to get more economic design and you have more time, you have to design each column at each floor. How many floors do you have? But for normal, we are designing this column for the whole building. Let's start today. We started to get the thickness of your footing. Next time I will tell you how can I get the dimension of the footing, then reinforcement, then do some check for shear and punch. Any question? Can you return your exam, please?